Hello all, welcome back to the tutorial session on the topic performance measure of regression in machine learning algorithm. So in this session, we are going to discuss about the content related to adjacent R square, median absolute error, mean square log error, root mean square log error and explained variance score. Normally we call it as EV score. So it's a continuation of part 1. So the adjusted R square tells how well the model explains data, while also considering the number of input features. In previous case in R square we have not considered the input features, but in this case we are considering the input features. So as per our example, so in this case we have input feature as 1. So that's why we are calling it as P as 1. So adjusted R square, the mathematical expression is given as 1 minus of 1 minus R square into n minus 1 divided by n minus P minus 1, where this P indicates number of input features. In this example, we have considered it as 1 as input feature. That is actual price of in square feet of your house we are considering as input feature. And R square indicates the basic R squared value and n indicates the number of data points. So in our example, we have considered n as 6. 6 number of rows we have. So it prevents vastly high scores when unnecessary variables are added as an input feature. We can see how it calculates. So as per the previous video, R square value is 0.9897 and n is 6 and P is 1. If you simplify this, your adjusted R square value will become 0.98713. As I said earlier, your adjusted R square value should also be lies between 0 to 1 and it cannot increase more than 1. So the model explains about 98.7% of the variation even after considering the model complexity. It confirms the model is good without using unnecessary input features. The median absolute error. It gives the middle value of all the absolute errors. It is not affected much by extreme errors or outliers. You can call it as it's a median of absolute error. It's a median of absolute error. Absolute error difference is actual value minus predicted value. And this is the actual same example you are going to use. This is actual value and this is the predicted value of 500 square feet size, house size. The actual price is 50 and the predicted price is 52 and the difference is minus 2 and absolute error you will get as plus 2. So if you sum all those values, no need to sum in this case. Since you are going to take only the median, you need to arrange all those data in ascending order and take the median. So if you do that, your median for this example, it's around median equal to 2 you will get. The typical prediction error is rupees 2 lakhs when ignoring extreme mistakes. So in this case you are getting answer as 2. The 2 indicates 2 lakhs when ignoring extreme mistakes. The typical error. The error is in this case is 2 lakhs. So most predictions are very close. So on only a few values have larger errors like this. That's the takeaway from median absolute error. So next topic is mean square log error. It is abbreviated as MSLE. It measures error after converting values into logarithmic scale. Mostly in this example I have used a ln in this case, since many algorithms while using in machine learning it will perform only in ln. Useful when dealing with growth data or larger ranges. So in mathematical expression way, MSLE which is equal to 1 by n of summation I equal to 1 to n ln of yi plus 1 minus ln of yi hat plus 1 the whole square. So yi is nothing but your actual price and yi hat is nothing but the predicted price, and n be the number of samples in this case. So in this example we are considering n as 6. Like 6 values is a actual price and y hat is the predicted price, and ln of y plus 1 gives you 50. Ln of 51 gives 3.932 and ln of y hat plus 1 gives you ln of 52 you will get 53. Ln of 53 you will get 3.970, and if you take the difference of this two you will get minus 0.038, since you need to square the term as per our equation. So if you square it you will get 0.001444. Same way you do it for remaining input parameters, and if you sum the square, since we need to sum and we need to divide by the number of rows samples. So if you sum all those data, you will get 0.006217 divided by 6. If you simplify that, you will get 0.001036. Since see here, the error is very less in logarithmic scale, meaning its predictions are proportionally accurate. With our model, the MSLE gives very least answer, least very small value, so the prediction is more accurate. The model performs well even when values vary in sizes. And RMSLE, it's a root mean square log error. So MSLE we have already know. So RMSLE is nothing but square root of 0.001036. It gives 0.032. So the average log based error is very low, indicating good prediction accuracy for growth type of data or increasing data. And the last one is explain variance score. It shows how much of the variation in data is captured by the model. For higher value means better predictions performance. So EV you can call it as it's 1 minus explain variance is given in mathematical way as 1 minus of variance of y actual price minus predicted price divided by variance of y. Now variance of y you can call it as, you can say sum of I equal to 1 to n yi minus y hat the whole square divided by n. See here the explained variance score. EV is a normal formula and variance of y is here. First we can calculate the variance of y, then only we can be able to calculate the explained variance score. So x is the actual price in input feature, and y is the actual price, and y hat is the predicted price, and yi minus y hat the actual difference between actual price and the predicted price, and yi minus y hat, this y hat indicates your mean value of your actual price, right? That is 50 minus 88.33 gives you minus 38.33. 65 minus 88.33 gives you minus 23.33. If you then if you need to take the square root of this actual difference and the yi minus y hat, this y hat is the mean. So if you take this square root, it will becomes 45, and this difference if you sum this, you will get 433.34. so variance of y indicates this square value, that is 438.34 divided by actual number of input, that gives you the variance of y. So in this case, the variance of y is you are getting it as 722.22. With that value, you are going to calculate the variance of E. In for short purpose, I have used y minus y hat as variance of E, that is error, as ei minus e hat the whole square divided by n. So how you can calculate the error? So it is e minus e hat. Yi minus y hat I am considering a mean, as I am considering this one. So the mean answer is 44.84. So 44, the mean e hat, where it is here, it is. So e hat you will calculate means you will get minus 2 plus 2 plus 2 minus 5 plus 2 plus 2 divided by 6. So if you do that, you will get e hat as 0.167. This 6 indicates number of input rows. In this case you have 6 rows, so you are getting 0.167. So now you are going to calculate the variance of E as sum of ei minus e hat the whole square. If you sum this all the terms, you will get 44.84, and number of feature is 6, so it is 6. So variance of E is 7.47. Now it's easy to calculate this variance of E and variance of y minus y hat, both are equal. For a short purpose, I have used variance of E. So now we can calculate the explained variance score as 1 minus of variance of E divided by variance of y. So variance of E just now we have calculated is 7.47, and variance of y already calculated in the previously, that is 722.22. So it's a typo error, I have written it as 0.18, and EV explained the variance which is equal to 1 minus of 0.01034. You will get explained variance score as 0.9897. It is equivalent to 1. So explained variance, you have calculated the most variances accurately, except 1.2 percentage is missing in this case. So it's an accepted model. So this explained variance score cannot increase more than 1. It should lies between 0 to 1. We'll meet you in another video. Thank you.